everybody, Leah and I are going to tell you about non-Euclidean geometry. So sit back, relax, and enjoy the show. Before we tell you about non-Euclidean geometry, we feel that it's important for you to understand what Euclidean geometry is first. Euclidean geometry is what we are all used to using. Euclidean geometry is based on 5 postulates. 1. A straight line segment can be joined drawing any 2 points. 2. Any straight line segment can be extended indefinitely in a straight line. 3. Given any straight line segment, a circle can be drawn having the segment as the radius and one endpoint as the center. 4. All right angles are congruent. The 5th postulate says, if 2 lines are drawn which intersect a 3rd line in such a way that the sum of the inner angles is less than 180 degrees, then the 2 lines will intersect each other if they are extended far.
There are 3 lines. Lines 1 and 2 intersect each other, and line 3 intersects line 1. The postulate says that if the interior angles made by lines 1, 2, and 3 are less than 180 degrees, then there is exactly 1 line that can be drawn parallel to line 1. This causes many issues because no one can really actually prove this postulate. And in fact, there are more proofs to say the postulate is wrong than those to say the postulate is right. Many mathematicians like Sakurai have tried to assume the postulate 5 is wrong in order to try and prove that it's right. After that, they proved many theorems based on the assumption that postulate 5 is wrong. Sakurai never really found a contradiction, but he concluded that Euclid was vindicated anyway, because he felt that all the theorems were odd to begin with. In the 1800s, several mathematicians also assumed that postulate 5 was wrong, and this gave way to new theorems about non-Euclidean geometry.
The idea of this new geometry shook the world for math and science. There were many people who doubted these new ideas. These doubts were resolved by the findings of models for the new non-Euclidean geometry. We are going to show you a few examples of both Euclidean and non-Euclidean geometry with Leah as our model.
Hey!
First, we're going to show you Euclidean. As we explained before, Euclidean geometry conforms to a simple n-dimensional plane. Leah. As you can see, Leah is showing us an example of Euclidean geometry. The angles made as she does a split are right angles, from her foot to her hip to the top of her head, to create right angles, which are part of Euclidean geometry. There are 2 fundamental types of measurements, angles and distance. We have both of those measurements when we're looking at Leah. 1. The length of her legs. 2. The angle that she is making using her legs and her body. In Euclidean geometry, Euclid uses the right angles as his basic unit. A line in Euclidean geometry is seen as a model of a real number line. A line segment, however, is part of that line and is bounded by 2 endpoints. Line segments have a definite length where a line does not. I am sure you all remember learning this when you were younger, but not like this. Now, back to Leah. Let's take the basics of Euclidean geometry and apply them to her, shall we? Length. There was a line stretching in either direction from Leah's legs, right? So if we just look at her legs, what are they? That's right, Leah's legs are 2 line segments. We can measure the length of her legs as well. Leah is 5'5", so let's assume that her legs are a yard long each. Got it? Great. Now on to the angle. First off, let's give Leah a hand for being such a good sport and doing a split in her first place. Applause. Woo! Now, consider the fact that she is made out of sticks. We'll have to give her a break with the angles. Maybe not exactly 90 degrees, but close enough. A right angle fits to a flat plane.
So now on to non-Euclidean geometry. There are 2 forms of non-Euclidean geometry, hyperbolic and elliptic. And just like before, I will be modeling for you guys, so stay tuned for that. First, let's talk about hyperbolic geometry. Hyperbolic geometry is also called Lobachevskian geometry. So there was a mathematician whose name was Lobachevsky, last name. And he kind of led the charge. Not really led the charge, but kind of kept the wheel of non-Euclidean geometry rolling. And looked at Euclid's postulates and turned around and found a couple contradictions. Well, not really contradictions, but he found that not all geometry, not all shapes and lines and things have to conform to a simple plane. So, because hyperbolic geometry is a form of non-Euclidean geometry, this means that the parallel postulate in Euclidean geometry is false. It doesn't make any sense. So, it's actually replaced. As we explained, the parallel postulate says that for any line, we'll call it line L, there is exactly one line that can be drawn parallel to line L. Well, in hyperbolic geometry, it's false, like I said. So, let's say we have a line, okay? We'll go back to line L. If we draw a point that is off of that line, in hyperbolic geometry, it says that there are an infinite number of parallel lines that can be drawn to line L. Okay? How's that?
Nice explanation, Leah. Can we have another demonstration?
Sure.
Whoa! Did you guys know that she could do that? Wow, I didn't. As you can see, Leah is our hyperbolic line. We will call the line above her line L. Even if we magically turn Leah around, there are an infinite number of ways to turn her where no part of her body will touch line L. This is also different from elliptic geometry as well. Great. Shall we move on to elliptic geometry?
Sure. Sounds good to me. I'm back. So, like Sarah told you, and like I explained before, in hyperbolic geometry, there are an infinite number of lines that can be drawn parallel to line L. Well, in elliptic geometry, there are no parallel lines. Okay? So, in elliptic geometry, lines have a negative curve to them. So, instead of curving up in a positive curve, they curve down. Okay? So, these lines, like I did, like I explained, actually bend backwards, which means that they will eventually intersect their baseline, or like we used before, line L. So the simplest model for elliptic geometry is a sphere. So let's look at a world. We'll look at the world. In this picture, we see that the angles of a triangle do not add up to 180 degrees, but they actually add up to more than that. So in this case, the Earth's axis, which we all learned in lower school, middle school, wherever you learned it, is that one invisible line that goes straight through the middle of the Earth. Okay? Straight to the center of the Earth. In case you guys aren't wondering, like I'm looking at, Sarah's right here. Hi. Yeah. Yeah. See, partners stick together. See, that's a tangent. See, it's a tangent. Math joke. So, in this case, the Earth's axis is actually the baseline, okay? And when we're looking at the legs of the triangle, it's not that funny, Sarah. The legs of the triangle are the elliptic lines, so they all bend backwards. And we'll eventually, if we could actually look inside the Earth and see where they are and where that axis is, they will eventually intersect the axis of the Earth. Okay? So, no matter what line you draw, it's going to intersect eventually. It might take a minute, but it will intersect. So, Sarah?
The weirdest part of this specific triangle is, like Leah said, the angles add up to more than 180 degrees. This triangle has two right angles.
That's right, Sarah. Good job. Now to review. In elliptic geometry, there are no parallel lines. Okay? You have a baseline. Elliptic geometry, there's no parallel lines. In Euclidean geometry, there's only one line that can be parallel to the baseline. And in hyperbolic geometry, there's an infinite number of lines that are parallel to your baseline. So we hope you guys, understood what we were talking about. Hope you understood it. Hope you guys, got a little, what's the word? Hope you were inspired to pick up a book and maybe read about non-Euclidean geometry.
Math can be fun.
Math can be fun, and there are many ways of using non-Euclidean geometry. There's actually, remember that lady I was telling you about, who actually crochets non-Euclidean geometry, where I myself, I crochet Euclidean geometry, which we have a couple videos of that, right?
Yeah, we had that,
we have a couple videos of that. So thank you guys for watching. Hope you guys enjoyed yourselves. Hope you guys learned something. And we'll see you guys later.